right-hand door edge. If you wind counterclockwise, the iron starts to travel around behind the door and you can't see what's happening. And when she comes out, if she doesn't want to keep it all, she'll go vertical and let that glass just drain off into a bucket, and that will eventually get put right back into the furnace. This is what's called a strip gather. Gives you a really nice uniform coat, and then we'll step into the pipe cooler, cool that pipe down. A lot of temperature involved with getting that gather of glass on there. Wiping off that water, you don't want to get things too slippery with all that glass on there, and then head right back to the reheat chamber. Now, to your right of Claire's left hand is the discolored end of the pipe. We affectionately refer to that as the hospital zone. You can see it in the pictures and you can imagine why. Okay, that's the hot part of this pipe. But you can see, and Claire was an excellent demonstration of it. Because of the weight, you have to be able to reach as close to the glass as possible to lift that glass in the air. The farther away from the glass you pick it up, the heavier that glass is going to get. So you see, she was able to cool it down, choke right up to that darkened end of the pipe, and then basically run that back to the rail. Now, they'll work together as a team. You can see Claire has the paper tool on there. She is cooling the tip of the bubble. And she's got, the rest of the team ready to, they're helping to assist with the turn and then getting ready to start to add air to the process. It's a great camera shot right over her shoulder, looking right in the reheat chamber. Now, the yoke that goes into the reheat chamber is on wheels that allows us to change that pivot point as you roll it in and out, so minimize that weight differential we talked about when you're overhanging the rail. And you'll see Claire and the entire team use gravity whenever possible to start to change the shape. Heat, centrifugal force, and gravity are glass blowers' three favorite tools. So now we're going to use the assistants to inflate this. And Claire will be the control. She's got the steam pad on the tip, making sure we don't blow it too thin, and watching how that bubble inflates. What's that? I don't know if they can adjust that or not. Let's see if I can get her attention. It's actually the person sitting right there on the floor, right at the other end of the bench. And you don't have to blow real hard. On a piece this big, blowing harder than we would on something a little smaller. But it's not like you're blowing everything you have to get this thing to inflate. Good glass blowers, and you've blown glass, Claire's blown glass for well over 25 years, and you just get the glass hot. That's the key. The hotter this is, the more easily inflated it will be. Using gravity, again, to ease that off the iron. And then cooling that lower half of the bubble. Anytime you draw temperature out of one part of the bubble, you get inflation in other parts of the bubble, and that's critical to the process. Now, at some point, we do need to remove this vessel from the iron. And so we need to, fairly early in this process, determine how that's going to happen. The team is heating her jacks, putting some wax on them. So Claire and her team are going to start to cut a constriction fairly close to the end of the iron, but probably into the pattern. And it's on this constriction that we'll eventually be able to break this vessel free. Now, it's kind of a worthless little fact. If you have a giant chocolate bar, and it has no lines in it, when you break it, you get a very jagged and broken edge. Scientists call that conchoidal cleavage, meaning it doesn't cleave or break in a straight line. That's what glass does, okay? So if you take that chocolate bar then and you put all the lines in it, you get the squares or the bars. That's what this jack line that we're going to install here does. It becomes a predetermined weak spot in the bubble. A little bit later in the process, you'll see Claire exploit that weakness and be able to break the glass free and get it to break where she wants it to break. If you don't have that jack line or neck line, some people call it a cut line, in your bubble, your chances of successfully removing this are pretty greatly diminished. So an important part of the process. So they're building heat into the shoulder, and then they'll start to cut this constriction right off the end of the iron. Claire's putting on a little extra Kevlar or Nomex protection. You'll realize that glass isn't moving, but we're at probably 16, 1700 degrees. You can actually get a radiant burn in this part of your arm. You're gonna have to touch the glass if you're in there that deep. So the team is ready to protect her arm with a paddle. And she may, depending on how long the ultimate goal is here, actually elongate this and cut the jack line at the same time, allowing you to do two things at once. You can see we're starting to build severe temperature into the backside. The backside of the iron is off the opposing rail, so yes, we're using gravity to elongate this. And Claire's going to reach up there with two hands and start to cut that constriction. This is tricky. It's actually one of the hardest things to learn to do, because if your jacks are not perfectly perpendicular to the iron, you start to get off kilter a little bit, and you create a corkscrew pattern. You need that nice, gentle constriction right off the end of the iron. Team diving in there just to help protect that arm. And you can see that constriction right off the end of the pipe. And here we're going to go back for the inflation again. Now, most glass blowers do what we call walk up on a shape fairly slowly. If you blow glass too thin, the process is over. You can't really thicken it. Very little you can do to save it. And we're probably using the glass different than Claire is used to using. I know we are using the glass different than they use in the studio. And glasses, while we all use soda lime glass, they can be dramatically different. This is what we call a long soda lime glass. And the version we're using in these furnaces now was actually designed by the manufacturer for our electric equipment, because it was chewing up furnace doors, the old stuff. And so, yeah, there's a great example there of elongating, letting gravity pull that off the iron, and cutting that jack line at the same time. And there's that going horizontal, and then going for the inflation. If you look off the right-hand side of that screen, you can see the extra clear that isn't colored yet, and that's that reservoir that we're going to inflate into. Inherent to the glass blowing process is the very tip of the bubble will always be the hottest. It's the last thing to come out of every gather. It's the first and last piece of the puzzle in and out of all the reheat chambers. And if you don't chill that bottom in one way or another, you'll blow out through it. And as beginners, we've all done that. You just blow the bottom thin and the process is over. So we spend a lot of time marvering the tip, cooling the tip, putting air on the tip, or like I say, using that newspaper tool just to chill the tip so that we get inflation somewhere else in the process. And so it's really a series of repetitive steps. It's cool the bottom, inflate the shoulders, reiterate that jack line, and then head right back into the heat.